For as long as we've been looking up, we've had this idea of our Milky Way as this kind of calm, flat, spiral galaxy, right? But what if I told you that entire picture is just completely wrong? It turns out our galactic home isn't serene at all. It is alive with these absolutely colossal, rippling waves.
Okay, so let's do a quick thought experiment. Picture the Milky Way in your head. I bet you're seeing that classic image, the beautiful spinning pinwheel of stars, all nice and flat, super predictable. But seriously, what if that image, the very foundation of our cosmic address, is just not the whole story?
Because, well, it's not. The latest data is pretty clear. Our galaxy isn't static. It is alive, it's dynamic, and it is full, absolutely full of these massive, moving waves. So, let's dive into our first piece of evidence. And it's a big one. I mean, a truly enormous discovery. And we have the European Space Agency's Gaia space telescope to thank for it. They're calling it the Great Wave. And believe me, it is completely reshaping how we think about our galaxy's entire structure.
All right, to get a sense of scale here, just remember, our galaxy is a staggering 100,000 light-years across. It's almost impossible to wrap your head around. And this wave we're about to talk about, it's playing out on that truly immense cosmic stage.
So what is this Great Wave? Well, picture this. It's a vast ripple moving through the galaxy's outer disk, and it's affecting stars from about 30,000 all the way out to 65,000 light-years from the galactic center. I mean, that's just huge. And how did we even find it? That's all thanks to Gaia's incredibly precise 3D mapping of millions upon millions of stars. It's only with that data that scientists could finally spot this pattern and confirm it exists, and this was just confirmed in 2025.
Okay, to really get what's going on here, we need to touch on a quick physics idea, the traveling wave. And this is the key part. The stars themselves aren't like flying across the galaxy. It's not that at all. Instead, think of it as a disturbance, an oscillation that moves through the stars.
And you know what? The European Space Agency came up with the absolute perfect way to think about this. They said it's much like the wave moving through a stadium full of fans. You know exactly what they mean, right? The fans don't actually run around the stadium, they just stand up and sit down. It's the wave itself that travels.
And it's the exact same idea in space. Just like those fans, the stars are moving up and down, kind of bobbing perpendicular to the flat disk of the galaxy. So one group of stars rises, and that motion travels to the next group, and so on. Then the Milky Way's own gravity pulls them back down, which keeps the whole thing going. A cosmic oscillation that just keeps traveling for tens of thousands of light years. It's incredible.
Okay, so a wave that spans a huge chunk of the galaxy is already pretty mind-boggling. But believe it or not, this story gets even more fascinating, because it turns out there's another similar kind of ripple happening, and this one is right here in our own cosmic backyard.
Yeah, let's meet the Radcliffe Wave. This thing was first spotted back in 2020. It's this massive, kind of undulating chain of gas clouds and star nurseries, basically the backbone of our local spiral arm. And get this, just recently, in 2024, scientists confirmed that it's not just shaped like a wave, it's actually waving, it's moving.
So let's put these two side by side for a second. The Great Wave, that's the big one, way out in the distant outer disk of the galaxy. But the Radcliffe Wave, it's smaller, sure, only 9,000 light-years long. But it is unbelievably close to us. At its nearest point, it's just 500 light-years away. That's nothing in cosmic terms. It's been hiding in plain sight this whole time.
And that proximity? That's where this story takes a truly stunning turn. This isn't just some abstract cosmic thing happening way out there. Nope, we are directly involved. This is personal.
So remember, this thing is 9,000 light-years long. That makes it the biggest single connected thing we know of in our entire neighborhood.
And again, at its closest, it's just 500 light-years away from us. That is practically our next-door neighbor in the grand scheme of things. So what does that actually mean for us here on Earth?
Well, it means we are, right now, literally surfing this wave. You heard me. Researchers actually traced our solar system's path and figured out that we crossed through this thing about 13 million years ago. And when we did, we passed through a region that was just bursting with dying stars. They called it a festival of supernovae. And because of our orbit around the galaxy, guess what? We're going to cross right through it again in another 13 million years.
Okay, so let's recap. We've got these two immense waves, one that's galactic-sized and one that's local. We can see them moving, we know we're interacting with one of them, but the biggest question of all is still totally unanswered. What in the universe is causing all this?
I mean, really think about it. What could possibly be powerful enough to make an entire galaxy ripple? What kind of event has enough juice to literally displace billions of stars and create a wave that travels for tens of thousands of light years? The cause has to be just as epic as the effect we're seeing.
And you can bet scientists are racing to figure this out. The leading theories are all pretty dramatic. So let's look at the prime suspects. First up, maybe a smaller dwarf galaxy smashed right through the Milky Way's disk, like a stone getting tossed into a pond. Or maybe it was the shockwaves from chains of massive supernova explosions. It could even be some kind of disturbance caused by the mysterious pull of dark matter. Or maybe it's something we don't even understand yet.
But here's a really fascinating little twist in this whole mystery. When it comes to our local Radcliffe Wave, the analysis of its motion suggests, well, you don't actually need dark matter to explain it. Turns out, the gravity of just the ordinary matter, the stuff we can see, seems to be enough to keep it waving, which, honestly, just adds another layer of complexity to this whole puzzle.
So, where does this all leave us? What's the big takeaway? Well, these discoveries are pretty much forcing us to just throw out that old static picture of the Milky Way. We have to draw a completely new cosmic map.
The bottom line is this: our galaxy is not some static picture in a textbook. It's a living, breathing, dynamic system that is in constant, beautiful motion. It's a place of epic waves and hidden structures, and it's so much more complex and active than we ever imagined. We don't just live in the Milky Way. We live in a galaxy that is literally alive and waving.
And that just forces us to ask one last, really thrilling question. If a wave that's 9,000 light-years long was right next door to us this entire time, hiding in plain sight, what other incredible secrets about our cosmic home are still out there, just waiting for us to find them?